In our previous video, we have seen how actually insertion sort algorithm look like. In this video, we are going to derive time complexity for average, worst, and best cases. So if you remember how our algorithm looks like, this is how we have wrote the function of insertion sort, right? So what is the input we do for deriving the time complexity? The first input we need is the size. So size here is n, and second is basic operation. So what do we mean by basic operation? Those who don't know how we calculate time complexity, for them I just give a brief introduction. We basically calculate how many times the basic operation is executed. So to find out how many times it is executed, we should know which operation or which line of the code is a basic operation. And basic operation is in general term we consider as the line which is executed every time, right? So can anyone tell me which among these line is the basic operation? So if you see, we don't consider the loops, right? We consider the actual operations. So if you see this, some of you may say this is the basic operation. Do you think this is happens, this is executed every time the loops or when we iterate to the loop, this is executed every time? No. It is only executed when this condition is true. Then only you are going to iterate through this, right? It means that every time this condition we are checking, this comparison we are checking. So this is what my basic operation. So my basic operation here is to check whether whatever the element I have is less than or greater than key. Right? This is my basic operation. So basic operation is comparison. Now consider the best case. Okay. For example, let's consider the best case. Okay. Consider the best case. Best case means when given array is already sorted. Array is already sorted. If given array is already sorted, let's say considered 1, 2, and 3 and 4. Okay. So what I'm going to do in my first iteration, I'm going to compare 2 with 1, and I'm going to find that no, it is not less than 2 is not less than 1, so it's gonna remain same. The position gonna remain same. Then in my second iteration, how many comparison I made? One comparison. I'll compare 3 with 2, and I'll say that 3 is greater than 2, so I don't need to change again. So these positions remain same. So one comparison I made. Then in third iteration, 1, 2, 3, 4. So I'm gonna check 4 with 3. I'm going to see no, that 4 is greater than 3 and it is right position. So it is at the right position. So one more comparison I had. So I have three comparisons. I have three comparisons. So every iteration, how many comparison I had? One. And this loop is going for, if you see this loop, n minus 1 times we are going to do it. So I can write if c of n is the number of times the loop going to execute it or the comparison going to happen is, so c of n will be sigma I equal to 1 to n minus 1 and 1, because we are comparing 1 at each iteration. So if you solve this, you're going to have n minus 1 minus 1 plus 1. So minus 1 plus 1 is this, so n minus 1. So you get time complexity in terms of theta of n in the best case. In the best case, if you have understood. If you don't understand how time complexity is derived, you can refer to our previous video where we have seen how to derive time complexity and we have solved good number of questions there. Okay. Now, what happens to worst case? Or what happens in worst case, guys? So worst case is when given array is already sorted in reverse order. in reverse order. For example, 4, 3, 2, 1. Now in first iteration, what I'm going to do is I'm going to compare with 3 with 4. So yes, this needs to change. So this, how many comparison? 1. In second iteration, 2 with 4. Yes, so 4 will come here. 2 with 3. Yes, 3 will come here and 2 will come here. So how many comparison I made? 2. 2 with 4 and 2 with 3. In third iteration, I'll make, sorry, and 1 will also come. I'll check 1 with 4. Yes, so 4 will come here. I'll check 1 with 3. So 3 will come here. 1 with 2. Yes, 2 will come here and 1 will come here. So 3. So 3 plus 2 plus 1, that is 6 iterations. 6 comparison, my bad. So we had 6 comparison. So basically, if you see here in this case, this is also executed. Okay, this is also executed, and we have taken care of this thing also. Correct? So if C of n is the total number of comparison, so the outer loop goes from I1 equal to n minus 1, and second goes from j equal to 0 to I minus 1, 1. If you solve this function, what you get, I equal to 1, n minus 1, I, if you solve I this here, so I minus 1 minus 0 plus 1. Correct? So which is nothing but sigma I equal to 1, n minus 1, I. So which is nothing but 1 plus 2 plus 3, so on n minus 1. And this is nothing but n into n minus 1 by 2, which is nothing but from the, if I write it, it is n square minus n, and which is highest degree is square. So asymptotically, we write that it is of the group n square. So time complexity of insertion sort in worst case is O of n square. So if you see here, quickly we can write it 3 points. The best case, average case, and the worst case. So here what we got was best case was n. Here is n square and n square, because average, what we'll consider is that some are jumbled, right? Means some are sorted and some are unsorted. We're going to consider it that way. Are you getting it? So this is what we're going to see. Considering now about space complexity. So if you see, we don't need any, this. So O of 1 will be my space complexity. Okay, space complexity for the insertion sort, right? In our next video, we are going to see some more examples on insertion sort so that you can get a quick hands-on this algorithm. And followed by, we are going to see advantage and disadvantage of this algorithm. And at the end, we are going to see what are the real world applications of this insertion sort across the industry or across the world in our real life. And most probably, we are going to add a video specifically for the insertion sort, in which we are going to discuss the most frequent question asked in the interview with perspective of insertion sort. So if you like this video, please do like, share and comments. Thank you.